So today's lesson, I'll pop in and out of the screen, but it's going to be our notes and our lesson for GCF, or greatest common factor. So pause the video right now and take a moment to get out your math notebook and get out your notes. If you don't have them at home, I linked the file directly underneath this YouTube video, and you can print it off or copy it on a piece of paper. So I would love to meet you on our GCF notes. So if we look at the table of contents, our GCF and LCM notes are on pages 3 and 4. So I'm going to flip all the way to page 3. It should look something like this. So the first thing I'd love you to do is grab something to write with. I'm going to use a couple different colored pens. So you can grab your colored pencils. You can use a regular pencil. I'm using orange, blue, and green today. So feel free to match mine if you'd like. So the first thing we'll do is factors. I'm going to use green for this. So it says a factor is multiplied to get a number. So I'm just going to underline my key information. Factor, multiplied, and I'm going to circle the factors here. There's a factor of 1 times a factor of 6 to give us the number 6. We have 2 factors over here as well. 2 and 3 are also factors of 6. So I'm going to put a big box around this next piece that lets us know that the factors of 6 are 1, 2, 3, and 6. Next, I'm going to go to multiple. I'm going to use blue for this one. So on our notes, it tells us that a multiple is the product of a number with another number. So product is the answer to a multiplication problem. So I'm going to underline multiple and product. Next, I'm going to circle all the multiples of 4 that are listed below. So I'm going to circle 4, 8, 12, 16, and 20, and these 3 dots means that I could continue counting up the multiples of 4. So then we have some questions. Is 16 a multiple of 4? We said yes, because it showed up on my list, or I knew a math fact to get there. 4 times 4 is 16, so it's a multiple. Is 18 a multiple of 4? The answer would be no, because we do not land on an 18 when we are counting up the multiples of 4. And the last part of this intro page, I'm going to use orange. We need to remind ourselves of the differences between prime numbers and composite numbers. So prime numbers are plain. I'm going to underline that information. Prime numbers, plain. This means they only have 2 factors, 1 and then the number itself. So I'm going to just double underline only 2. For example, 5 is prime because 1 times 5 is the only factor pair to equal 5. So I'm going to underline 5 is prime. Another example here, 29 is prime because 1 times 29 is the only factor pair to equal 29. There's no other ways to make it. So I'm going to underline the other example, 29 is prime. Next, we have composite numbers. So composite numbers, another way to think about them is that they're more complicated because they have more than 2 factors. So I'm going to underline composite numbers, complicated, more than 2 factors. So 9, for example, is a composite number because 1 times 9 and 3 times 3 both equal 9. So it has more than just 1 factor pair. So I'm going to underline 9 is composite. Another example, 24 is composite because its factors are 1 and 2 and 3, 4, 6, 8, 12, and 24. 24 is definitely composite because it has tons of factors in its factor list, way more than 2. So now that we've gotten that introduction out of the way, I would like you to open up your notes and I would like us to look at the left side of our notes all about GCF. Today we're going to learn 3 different ways to find GCF, and GCF stands for greatest common factor. So greatest means biggest. So write that down if you'd like. Greatest means biggest. Common means something that you have in common or something that you share. So I'm going to write shared. And then we have factor. So the GCF is the greatest common factor, and that is our whole lesson for today. So we're going to go over 3 different ways to find GCF, and you might like 1 or 2 of these better than the others. So the first way that we're going to zoom in on is to just list the factor pairs or the factors. So that's this very first box. So we're going to do this for the numbers 12 and 36, and I'm going to show you 2 different ways you can list them. So the first way is to list them by factor pairs. So for example, under the 12, I could write the factor pair 1 times 12. I also am going to just keep going in order. I'm going to try a 2's fact. I know that 2 times 6 is also 12. I know that 3 times 4 is 12. And if I try out my facts, I have a 1 fact, a 2 fact, a 3 fact. I do have a 4 fact, but since it's already listed, I know I'm going to start repeating my numbers. So my list is complete. I'm now going to do the same thing for the number 36. So I'm going to do 1 times 36. A 2 fact, I know there has to be 1 because it's an even number. And if I'm not sure what it is, I can always do this off to the side. So if I'm not sure 2 times what number makes 36, I can use division to find out. So off to the side, I'm going to do 36 divided by 2. And I'm going to see if I can figure out the other factor. So 18 was my other factor. Next, I'm going to try a 3's fact. Now I know that there's going to be a 3's fact because I have a great trick. If you add up the digits and it's divisible by 3, you know there's a 3 fact. So because 3 plus 6 is 9, I know there's a 3 fact. So I'm going to do some division again off to the side and figure out what it is. Three times 12. A lot of you know that because you know your 12's facts. If you don't, I just showed you again how division can help us find missing multiplication factors. Okay, 4 times 9 is 36. 5 fact, there is no 5 fact, but 6 times 6 is 36, and my factor list is complete. Okay, the other way that you can choose to do this, some people like to just list the factors. I'm going to swap to orange for a moment, and I'm going to start looking for the GCF, or the greatest common factor. That's the biggest shared factor that both of these numbers have. So I'm going to look at my list, and I'm going to start circling the factors that they have in common. And I'm noticing that they actually have a lot of factors in common. But then, once I found every factor in common, I noticed that 12 is the GCF, or the greatest or the biggest common factor that they share. Another way to do this in a list is just to look and find the biggest number that shows up on both lists. So my GCF is 12. Now this is a great way to find greatest common factor if you feel comfortable with all of your math facts. So if you're not confident in being able to list all the different factors of a number, I'm going to show you 2 more ways to find greatest common factor without knowing every number on the list. So these are called prime factor trees. And so they're called factor trees because you're going to draw branches off of the numbers, and you're going to try to break these numbers down into their factors, and your branch stops growing once it's reached a prime number. So a prime number is a number where the only way to get there is 1 times itself. So I'm going to draw 2 branches off of 36. Now I need to think of any factor pair for 36. So if the only thing you can think of is 4 times 9, that's what you might write. And everyone's trees might look different if they choose different factors, but all of our final prime branches will agree if we've done our math correctly. Okay, so then I look for 2 more branches off of a number. Now, 4 can be broken down into 2 more factors. So I know that a way to make 4 is 2 times 2. Okay, the only factor pairs that we don't want on our trees are our 1's facts. We don't ever want 1's for branches. So now that I've gotten down to 2 branches with a 2 and a 2, I'm going to circle those branches because those are prime numbers. They are finished growing because I can't break down a 2 into anything else other than 1 and itself. So if 1 is my only option, it's 1 and done. So I'm going to do the same thing for my 9 branch. Let's break it down into another pair of factors. I know a way to make 9 is 3 times 3. And I know that those branches are also done because they're prime. So the prime factorization of 36 is 2 times 2 times 3 times 3. I've broken down the number 36 into 4 prime factors. Let's try this for 48 and then show how these prime factor trees can help you find GCF. So I'm going to draw my branches off of 48. So I've got to think of some factors of 48. Well, I know that 4 times 12 is 48. So I'm going to write 4 and 12. 4 and 12, neither one is prime, so I have to keep going. So I'm going to draw my branches off 4, and I know that that's 2 times 2, and those branches are prime, so they're done. I'm going to try this with 12. I know that 12 is 6 times 2. The 2 branch is done because it's prime, but I can keep going on this 6th branch. So 6 can be broken down into 2 times 3. And those are both prime because they only have 1 times themselves. So that was a lot of work to create these factor trees. But now what I'm going to do is I'm going to grab my orange marker again, and I'm going to show you how these factor trees can help you find the GCF without making the list that we did in the first option. So if I am looking for the biggest shared factor, I'm going to find the branches that they share. So in orange, I'm going to circle the branches that they have in common. I see a 2 branch over here on the 36 tree, and I see a matching 2 branch on the 48 tree. So they have a 2 in common, so I'm going to jot them on the list. It has a 2. Next, I'm going to look for another branch that they both have. I see another 2 branch, so I see a 2 branch here, so I'm going to circle it. And I see another 2 branch over here, so I'm going to circle it. So they had another 2 in common. I'm going to add it to the list, and I'm going to put a little multiplication symbol. Do they have anything else in common? Oh, I see a 3 branch over here on the 36 tree and a 3 branch on the 48 tree. So they also have a 3 in common, and I'm going to put it on my list. I don't see any other branches that show up on both trees, so I'm done finding the branches that they had in common. So what I'm going to do is multiply these branches together to get a number. 2 times 2 is 4, and 4 times 3 is 12. So my GCF for 36 and 48 is also 12. It's really interesting. So my GCF for 12 and 36 was 12. I also had a 36 and 48. Their GCF, or greatest common factor, was also 12. That's the biggest number that would show up on both of their factor lists. And I'm going to show you one more option, and then you're going to decide which one you like the best. Okay. This is called double prime division. Now, I want you to look at these little boxes. It's kind of like a division box, but it's flipped upside down. And it's called double prime division because we're going to be dividing 2 numbers at the same time. The rules of double prime division is you can only divide by a prime number. So our prime numbers are those very simple numbers that only have 1 in itself as a factor. So prime numbers that I like to try are 2 or 3 or 5 or 7 or 11. So there's these small numbers. Now, since 36 and 48 are both even, I'm going to divide by 2. So let's all write a 2 outside. I knew above that 2 times 18 was 36. So when I do 36 divided by 2, I'm left with 18 left over. We're going to put that below. Now I'm going to do the same thing with 48. Let's do 48 divided by 2. I can do the division off to the side. So if you're not sure, you can always do 48 divided by 2. Let's see what it is. 24 is what we're left with. Okay. Now we're going to double prime divide again. 18 and 24, do they have another prime number in common? Oh, I see a 3 fact. So I'm going to put a 3 on the outside. 18 divided by 3 is 6 left over. 24 divided by 3 is 8. Okay, I'm going to double prime divide again. 6 and 8, do they have a prime number in common? I'm going to divide by a 2 because they're both even. 6 divided by 2 is 3, and 8 divided by 2 is 4. 3 and 4 do not have anything else in common, so I cannot divide by any other prime number. I can't use a 1 because then that wouldn't change my 3 or 4, so I'm done. And what I love about double prime division is all I need to do is take all of these factors over here and put a big G around them. If I put a big G around these numbers, all those numbers together are my GCF, my greatest common factor. So let's multiply them and find out what this number is. I got a 2 times a 3 times a 2 And 2 times 3 is 6, times 2 is 12. My GCF of 36 and 48 is 12. I got the same answer as my prime factor trees. And then what I want you to do is I want you to just think, which one of these methods did you like the most? Okay, so I want you to be thinking of that and maybe even just write it down here in the box. Which way makes the most sense to you? And I want you to jot it down. So those were a lot of notes today, and I understand that. So what I really want to recommend that you do is go back and I want you to watch those one more time. But I really want you to think which method you like. People who really know their math facts, they might just like to list the factors. Some people can even do some of these lists in their head if they really know all their math facts. Now, I will let you know, this is not my favorite method because sometimes I feel like I miss a math fact. Prime factor trees, some people really like the layout and they like how that looks. And then all they do is find the branches on the trees that the numbers have in common, multiply those branches, and all those branches that are in common multiplied together are the GCF, or greatest common factor. I don't mind prime factor trees. I will let you know that my favorite is double prime division because I like thinking about division as a way to see missing factors. I also like that all I need to do is put a big G around the numbers on the left and I've got the greatest common factor.